represent?
Repeated root.
Sorry?
Repeated root.
Yes, repeated roots, because hence here when we break this down, we have s, which is raised to the exponent 1, and then I said you stop when you have the highest power, yeah, s. This s squared simply represent the repeated roots. It's basically the same thing with what we've been doing here. You see, we started with s to the exponent 1 and then s to the exponent 2. That's when we start. Similarly, we have this s squared. It's like we're having a combination of repeated roots and linear roots. So hence, we say s to the exponent 1, which is just s. We must just, then plus b s to the exponent 2. The 2, that's the highest power of s in terms of this guy being the repeated roots. Ne? Then plus c all over s minus 3. This s minus 3 is the linear roots. Ne? Are we all in the same page?
Yes.
So whenever you have a problem like this, yes, you can take the long way, solve it with the simultaneous equation, what we're doing here. But there's a simple way that you can solve this. You can basically get the value of c by using the hiding method, since we know the value of c is like we're having a linear factor. Ne? So we can say c is equals to what? 9 all over, we're not going to consider the factor of c. So s squared. Ne? At s is equals to what? What makes c to be?
It's 1.
Ma'am.
Sorry.
Is it 1?
Yeah, because where I can we check what are we gonna put at c to subtract? I guess so it's going to be positive 3, and then we
Yes,
hide
it's
that
possible.
3.
Oh, you're giving me the final answer.
Yeah.
Yes, I was looking for the value of s. At s is equal
Oh.
to 3. Yes. Sorry. So it's gonna be 9 s squared is the same as a 9. It's basically 9 over 9, which gives us 1. So we have the value of c as what? As 1. Ne?
Mm.
So now we are going for the value of b. How are we going to get b?
So when I have 3 things like a plus b plus c, and I want to use the hiding method, for example, A or C, re berekisitse, the B thing. So I can pick between A and B.
Okay, let me get your question very well.
So say when we, yeah,
We're having 3 unknowns, a, b, and c, yes?
how do I know like which to pick from when I want to use the hiding method?
Okay, initially when I explained the hiding method, I said the hiding method works when we have linear factors. Ne? Hence, with
Yes,
this
sir.
example that we did here, the first one, you can see we're having linear factors, we just use the hiding method. Ne?
Yes, sir.
But
Yes, sir.
the second problem that we did, we had repeated roots, which we cannot use the hiding method. Why? Because all these roots are the same.
Yes, sir.
Ne? But in this case, we're having a combination of hiding bargain of repeated roots and linear factors. Linear factor, which is s minus 3. So the reason why I started with c is because c is a linear factor.
Yes, sir.
Okay. Did I answer you?
Mm. Mm. So say, so you used the I can say with the hiding method, we sort of cancel out the for the variable we're looking for, and we look at the other equations like a over something or b over something. So if there's three, how do I know which one to use?
Okay, I think it makes sense with an example. Let's say maybe okay, let's start with this one. We have 25 s plus 11 all over s plus 2 s plus 3. Ne? Our partial fraction is going to be a all over s plus 2 ne? Plus b all over s plus 3. We're looking for what? We're looking for b. Ne? If we're looking for b, we always consider what is on our left hand side. Meaning this factor s plus 3, we're not going to consider it. We're going to look at what is left already. So it's going to be 25 plus 11 all over s plus 2. Ne? Add
Okay.
s is equals to what? What makes this denominator undefined, which is negative 3. That's when we're going to say 25 into negative 3 plus 11 all over minus 3 plus 2. And what is the answer?
Before
64.
yes.
64. And then for A, we basically do the same thing. Ne? For A, we are going to do the same thing. Since we are looking for the value of A, ne? Since we are looking for the value of A, we are going to say A is equals to, ne? We are not going to consider this factor of A, which is s plus 2. Ne? What is left is 25 s plus 11 all over s plus 3. Add s is equals to what makes the denominator of A to be undefined, which is minus 2. Minus 2 plus 2 is going to be 0. A over 0 is undefined. And then we substitute here 25 into negative 2 plus 11 all over negative 2 plus 3. And then we get the answer. Does it make sense?
Yes, sir.
And then in this problem, we are trying to get the value of what? The value of C. Ne? Meaning what we are not going to consider what? The fact, we always look at what we have on the left hand side. We're not going to consider the factor of what? Of C.
Okay.
Hence we have C is equals to 9 all over what is left, which is s squared.
Okay, sir.
Is equals to 3, and then we get the value of C.
I see, sir. Thank you.
You're welcome. So now how are we going to get the value of B?
We're going to use the long method because it's repeated values. So we're going to say we can't use the hiding method on this one because there's repeated.
Okay.
Am I correct?
You there is a way that we can get the value of B. I will explain, but I love the fact that you're reasoning like that. Ne? Okay. If you look at the value of what we're going to do now, we're going to do some manipulation. We are manipulating here. We're going to do some manipulation. Ne? We can get the value of B. Why? Because we are not only limited to repeated roots on this question. But if it was only repeated roots, we're not going to do that. But since we are not limited to repeated roots, and then we can get the value of B. Ne? You can say B is equal to, we're going to not consider the factor of B. Ne? We're not going to consider the factor of B. So what is left is 9 all over s minus 3. Ne? At s is equals to what? What makes B to be undefined? We'll take both roots, it's fine, don't worry.
0.
0. And then we're gonna say 9 all over minus 3, which give us what? negative 3. Ne? So you can see now we have the value of C, we have the value of B. What we can do now, since we know or the factor of A and the factor of B are the same, ne? I mean the denominator are the same, these are repeated. We can just say we have 9 all over s squared s minus 3, which is equals to A over s plus B s squared plus C over S minus 3. But look, we do have the value of B, which is what? Is negative 3. We do have the value of what? Of C, which is 1. But we do not have the value of what? Of A. We don't have the value of A. So we can choose S value to be any number that we want and then solve. We are going to get the value of A. We can choose S to be any number that we want, either 1, 2, or 3. Then we are going to get the value of A. So we can choose the S value to be what? To be 1. If we choose the S value to be 1, we are going to end up with what? 9 all over 1 squared 1 minus 3, which is equals to, we have our A all over 1, and then minus 3 all over 1 squared plus 1 all over 1 minus 3. Please punch everything on your calculator for the left hand side. Tell me what do you get. 9 all over 1 squared into 1 minus 3. 1 squared is the same as 1. I'm just doing this for the sake of teaching. One minus 3 is going to be negative 2. So it's 9 all over negative 2, which is equals to A over 1 is the same as this guy. So it's minus 3. And then 1 all over 1 minus 3. 1 minus 3 is negative 2. And then we're going to transpose everything to our left hand side. So we're going to end up with A, which is equals to minus 9 over 2 plus 3 plus half. What do we get?
Negative 1.
Negative 1. We have A is negative 1. Ne? So we have our A, which is negative 1. Ne? So now we are required to do what? Remember the question? They said we must determine what? The inverse Laplace. Determine the inverse Laplace of this. So it means that we need to get rid of this information here so we can use the same space. Yes, ma'am.
So I can solve it this way if the repeated root is not like a s minus something bracket square.
Even if it was okay, let me think.
Like the previous question.
Yeah, if it's not like the only that, you know, if you reach a point whereby you're having something like this, just take the long road. Even if you do have a linear factor multiplying this, just take the long road. It's gonna save you. If you
Okay.
have this type, and then you can solve it like this.
Okay, sir.
So to solve this, we have y of s, which is equals to 9 over s squared into s minus 3. We can break this down as a over s plus b all over s squared plus c all over s minus 3. Ne? But we have calculated the value of a, the value of b, and the value of c. Now, the value of a we said is minus 1 over s, and then the value of b we said is what? It's negative 3 all over s squared. The value of c is what? Is 1 plus 1 all over s minus 3. Ne? So we need to get the inverse. The inverse of y of s is y of t. Ne? I'm gonna pick this one first. So the inverse of, I said the inverse of a constant over S is going to be what? That constant, -1. Ne? And then now this is your turn. You need to identify which rule we are going to apply here. Which rule are we going to apply?
It's rule 2, sir.
What does rule 2 says?
T to the power of n
To the power of n
and n factorial over s to
to
the
the
power
exponent
of
n1.
s.
Thank you so much. So we're trying to get what? To the inverse. We're trying to get the inverse. Ne? How are we going to get to the inverse? We need to identify n. N is what? Is 1. Ne? Do you agree?
Yes, sir.
So what will be the final answer?
The final answer will be -3 t and e to the power. No, no e, man. Sorry.
You're
Yeah,
looking
yeah.
at rule
Get
8
the-
now.
Yeah. I was looking at something else. Yes, yeah.
Yes, you're looking at
-3t.
rule 8 now because you said rule number 2. So it's going to
Yeah.
be minus 3t.
Yes, sir.
You understand? I remember the reason why is minus 3t is because n is 1. If n was another number, we're going to multiply and balance it, do what we were doing yesterday. But since n is just 1, we're basically multiplying denominator and the numerator by 1, meaning this guy is still going to give us the same answer. Ne? Okay, let's go to the last one. The last one, I'm going to take it as well. It's simple, minus. It's going to be positive 3t. Ne? Then this is your final answer.
Yeah, so I was looking at the following answers. I wasn't looking at the rule 8.
No, it's okay. I noticed. So this is how we do it. Should we try using the long method? Guys?
It's fine, sir. We understand the long method.
Yeah. Okay. It's cool. We are all agreeing I'm moving, ne?
Yeah, boo.
Okay, let me see. This is what we did now. What am I missing?
So are we also going to touch on completing the square?
Completing the square, we touched on it. We spent the lesson, like the whole lesson, on completing the square. So I said I don't want to mix those lessons. Hence today you see we are basically focused on completing partial fraction. But completing the square is basically going to be rule number 10, 11, and 12. 9, 10, 11, and 12 when you do the inverse.
Okay.
Yeah. Just looking for another problem that we can do here. Okay, let's just do a problem as a whole. So from this slide, you are actually given you're given use the Laplace. They say use the Laplace transform to solve the following IVP. Okay, use Laplace transform to solve the following IVP. Ne? So what do you have? You have 2 d squared y all over dt squared plus 5 dy over dt minus 3 y which is equals to 0. Why is 0? Okay, it's equals to 0. And then you need to solve this. You are given the condition or y of 0 is equals to 0. I wanted a condition that has a number, but yeah, y of 0 is equals to 4 and y prime of 0 is equals to 9. Ne? So from the lesson that we had yesterday, I said what is the first step that you take whenever you have such problems?
Take the Laplace on both sides of the equation.
We are going to take the Laplace on both sides of the equation. And I emphasize on the fact that if you are having a constant in front of the derivative, you need to separate the constant. You need to use the square brackets. Ne? So we're going to have 2 into, what is the Laplace of d squared y all over dt squared?
S squared y s
Squared y of s
minus sy of 0
minus sy of 0
minus y prime of 0.
minus y prime of 0 plus, you see, 5. There's a constant in front of the derivative. Now I'm going to put the square bracket. Ne? And then the Laplace of this guy, Laplace of the first derivative,
Sy of 0.
as y of s
Oh, minus y of 0.
minus y of 0. Ne? Minus, what is the Laplace of minus 3y?
It's gonna be minus 3ys.
Minus 3 y of s, ne? Which is equals to 0. Ne? I'm begging you, when you solve this problem, it's gonna save you from making a lot of mistakes. First thing, take the Laplace, write it like this. Ne?
Sorry,
Yes.
sir.
Mm.
The place of 3y came wrong, mama.
I explained it yesterday that if you are having this type of a problem, you're just gonna say is the y is y of s. If the Laplace of a constant is y of s. When it's a
Okay,
constant like this, for example, if you have r of t, the Laplace of r of t is going to be r of s. So if we have the Laplace of small y, the Laplace of this is going to be y of s. For those who are doing control system,
okay, thank you.
Yes, thank you. So please follow these steps. Ne? First thing first, take the Laplace on both sides. Ne? After taking the Laplace on both sides, and then you're going to do what? Do some substitution. We have s squared y of s minus s y of 0. What is y of 0?
So
So it's going to be 4s, ne? Minus 9, because y prime of 0 is 9. Ne? Then you close plus 5 into s y of s minus 9, ne? Minus 3 y of s, which is equals to 0. Ne? You see what I did? I took the Laplace first, and then second thing, I substituted our condition. Now the third thing, I'm going to distribute. Yes,
the
it's
second
4.
bracket. Oh,
the second, oh, y of 0 is 4. Y of
Yeah.
0 is 4. Thank you so much. It shows that you guys are focused. It's 4. Ne? And then the second thing, we're going to distribute this constant inside our brackets. Ne? So we're going to have 2 multiplied by s squared y of s is 2 s squared y of s. Ne? Minus 8 5s ne minus 18 plus 5s y of s ne minus 20 minus 3 y of s, which is equals to 0. Ne? So from this point, we're going to group anything that has y of s on its own. Okay, fine. Bon, I'm telling you the answer. What is the next step after this one? What is the next step after this one?
So you just said it. So you group the.
I want to hear it from you.
You're grouping the like terms. So the ones with s y of s and the ones with s and the constants.
Remember our objective or our main aim here, according to the rules that we went through yesterday. Let me check. We said we need to make y of s or x of x subject to the formula. Ne? Subject to the formula. So it means for whatever that has y of s, we're going to keep it on the left hand side. This one, and this one, we're going to keep it to the left hand side. And then everything else is going to the right hand side. Ne? So we're going to have 2s squared y of s plus 5s y of s minus 3 y of s, which is equals to, we have 8s, we transpose this negative 8s to the right hand side, and then plus 20 plus 18, ne? 20 plus 18 is 38, so it's basically 8s plus 38 plus 38, and then we take out the common factor here of y of s. What is left is 2s squared 2s squared plus 5s minus 3, which is equals to 8s plus 38. Ne? So our y of s is equals to 8s plus 38 all over. Yesterday I said before you divide our right hand side with the denominator of our left hand side, first check if you are able to factorize that. Can you factorize 2s squared plus 5s minus 3? Can you do it?
Please repeat your question.
Can you factorize 2s squared plus 5x minus 3?
Yes.
What are the
Let me check on the guide. Hold on.
Factors are 1 over 2 and negative 3.
1 over 2 and negative 3? Okay, these are the real values. It means the factors will be 2s minus 1 and then s plus 3, right? Because if s is equals to 1 over 2, multiply both sides by 2, it's going to be 2. S is equals to 1, 2s minus 1. This is the factor. If s is equals to negative 3, you transpose it to the left-hand side is s plus 3. Yes, these are our factors. So we have our y of s, which is equals to 8s plus 38 all over 2s minus 1 s plus 3. How do we solve this?
Partial,
Partial fraction. Why?
because our what you call, our denominator is higher than our numerator.
The exponent of the denominator is higher than the exponent of the numerator. So we're going to use partial fraction. So this is you. Let's go to the next page. We have our y of s, which is equals to 8s plus 38 all over 2s minus 1 and then s plus 3. So it's 8s plus 38 all over 2s minus 1, 2s minus 1, s plus 3. So we're gonna have a all over 2s minus 1 plus b all over s plus 3. Let's get the value of a. The value of a is going to be what? 8s plus 38 all over what? All over s plus 3 at s is equals to what? At s is equals to what? One, is it 1 over 2, ma'am? Yes, it's 1 over 2. Ne? So it means what the value of a will be what? A into 8 into 1 over 2 plus 38 all over 1 over 2 plus 3. Give me the answer. The value of a. Quickly.
$12.
12. Let's do for b. B is going to be 8s
Negative.
plus 38 all over. We're not going to consider the factor of b. So it's going to be 2s minus 1 at s is equals to
Negative 3.
negative 3. So b is what? 8 into negative 3 plus 38 all over 2 into minus 3, ne? Minus 1. What is the final answer?
Negative 2.
Negative 2. Wait, where did I write the value of a? Okay. So now we are required to, remember we're trying to use Laplace to solve this problem. We're still doing the same problem. So it's going to be what? For this guy, we're going to have our y of s. We broke this guy into a partial fraction. So it's now going to look like a all over 2s minus 1 plus b all over s plus 3, ne? But we know that the value of a is what? Is 12 all over 2s minus 1 and then plus our b is what? It's basically minus 2 all over s plus 3, ne? This is our y of s. So we need to solve this. How are we going to solve this?
The first one, I believe it's rule number 7.
Rule number 7, yes.
And then we are going to say 12.
But ma'am, before you solve this, rule number 7, I know it as 1 over s minus b. However, in this case, we are having something here. We are having a constant. How is this number 7? Help us, slow learners.
We so for me, I just check. I check what's similar. So for me, that's the one that's most similar.
That's true. That's true. But for us who uh, as low learners, we want to understand what's going on here.
Okay, it's the
Citing
only
the
on
fact
the
that
rules, ne? It's the only one where when you check the denominator, there is only S minus B. So like there's no, all the other rules have like, squares and something like that, Yeah, so I just checked that, okay, because this one has, it's a fraction and and it's just you know, two numbers subtracting one another.
you know. So
So yeah.
okay, I hear you and thank you for your explanation. But how are we going to solve this if there's a 2 in front and according to the rule we don't have a 2? Remember what we did yesterday? We had a problem which I said if we are trying to get to the inverse, let's say maybe one of the problem that we did is, let's say maybe we have in fact the rule says n factorial s minus b to the exponent n plus 1. I said if you do not have n factorial on your numerator, you cannot go back to our f of t. Hence, the reason why I'm asking is because I think rule number 6 or 7 is 6 is e to the exponent bt. The Laplace of this is 1 over s minus b. So for us to move from this guy to this guy, we need to have what? The coefficient of s here to be 1. However, in this case, the coefficient is 2. How are we going to solve this guy? That's the problem. Help us, the slow learners.
We have to manipulate, sir.
You have to be manipulated. Yeah, you see, when it's coming from a guy, the ladies are gonna take it bad. Yeah, I'm joking. How are we going to manipulate, sir? How are we going to manipulate?
I think you're gonna say, like you're basically gonna times it by like 2 divided by 2. Like,
You know? Okay.
please help us, we forgot.
You can, yes, ma'am. Thank you so much. Yes, go ahead.
I mean, I can only think of taking out the 2, but the issue is it's gonna change the 1, and I don't know if that's okay.
It is okay. So we're gonna
It's gonna make the 1 1 over
1 over
2.
2. We can take out the 2 and then we're left with s and then minus 1 over 2. You get it?
Yes.
Minus 2 all over s plus 3. This we are familiar with. This we are familiar with. This one we know. This one we know. What is 12 divided by 2? Inverse of y of s is going to be y of t. And then what is 12 divided by 2 is 6. Ne? E to the exponent 1 over 2 t minus 2, e to the exponent is positive, so it's going to be negative 3t. This is how you get to your answer. So already you have 1 mark for this guy inverse, 1 mark for this, and then 1 mark for A, 1 mark for your B. Is A and B only here, and then 1 mark for taking the Laplace, 1 mark for the substitution, and then 1 mark for standard form, and also maybe sometimes 1 mark for making sure it's you take out this y of s. So it's basically 1, 2, 3, 4, 5, 6, 7, 8. 8 over 8, you get your full 8 marks. Partial fraction on itself, it didn't the marks, Leon. You're going to do this on the counter page. So yes, any question? Any question? Okay, I think I'm gonna stop here. I will see on Wednesday or Thursday if I cannot assist. If my schedule allows me, we are going to have class on those days because you wasted your time on yesterday. You were supposed to be in line with the content, but you were not doing your work from your side. Hence, we basically wasted yesterday's class redoing all those things because I wanted to do some of the problems that I said we are going to do together. You see, my laptop is gonna switch off now. Let me stop the recording for those who are not here. Oh, Jesus Christ. Okay, let me do this.